Okay, welcome. This is another subchapter talking about, this time, dimensional analysis, a new and another really important foundational block to solving for any kind of chemistry problem, really. So, dimensional analysis is any kind of conversion factors that are used to convert between units. So I've got some examples right here for you. We'll say 0.808 grams per cubic centimeter. That cubic grams per, I'll just go off on a little bit of a tangent here. Grams per cubic centimeter, that is really used for density. So we're given, in this example, we're given the density of some kind of substance. Could be an element, so it could be a compound, could be something. I'm not entirely sure, but we're given the density 0.808, and really there should be a leading zero. Sometimes I don't write it, but there really should be. I need to be modeling 0.808 grams per cubic centimeter. So the way dimensional analysis works is then you would multiply. If you're trying to get from grams to kilograms up here, you would multiply by 1 kilogram per 1,000 grams. So again, that would be a proper way of doing it. So that's a gram right there. That's a gram down here. They cancel out as I've done it there. Grams cancel out. And then you're left with kilograms on top. It's kind of hard to see because I keep going over it. But you're left with kilograms on top, kilograms per, and then we're actually converting from meters. So yeah, the way it would work, this is a pretty complicated example to start on, but if you can understand this, you'll really understand it. We're going from cubic centimeters down here up to cubic centimeters up here. 100 of them, 100 cubic centimeters per meter. We're going from centimeters to meters. But then, yeah, this is a really complicated example to start. Sorry, I should have thought this through. We have brackets. And since it's cubed, we keep the cube on the outside here. So we're saying, I'll just rewrite this. We're saying 100 centimeters cubed per meter. So anyway, the way it's working, it's kind of hard to read now, but we have 0.808 times 100 divided by 1,000. We're getting 1,000 there, equal to, but then we would actually get 808 kilograms per meter cubed. Well, you have to understand, let me just give you another example. That was a really complicated example to start on. I'm sorry. And I really should have given a more basic example. We could say, no, this one's getting a little advanced with cubing again. 5 trucks. This is a new example. 5 trucks, and we could say, we have to know this information ahead of time. We have to know or be given. Know or be given. So anyway, I apologize once again for starting with such a difficult example. But the way it's supposed to work is, let's say you have 5 trucks, and you know or you are given in the problem that each truck has, let's say, each truck can carry, one truck is, let's say, equal to 5 crates. So we can say one truck, we can multiply by this. One truck is equal to 5 crates. And you could say, how many crates are there? The question could be, how many crates are there with 5 trucks when you get 5 trucks? So you would just simply multiply 5 times 5. Because the way this is set up is, once again, it's conversion factors to convert between units. So right now our unit is trucks and we're trying to get to crates. So we just use this conversion factor that we're given in the problem. So we'll say 5 trucks times 5 crates over one truck, which we just cancel out the trucks. Because those units cancel, and then we are left with 25 crates. Again, 5 trucks times 5 crates would give us 25 crates. So that's a pretty brief explanation on dimensional analysis. Again, I'm sorry, I started off with a really crazy example here, and I followed it up with something, I think, a little more basic. Okay, so anyway, I really hope you understand dimensional analysis problems can get pretty lengthy, but they are really important in solving for anything, really. In chemistry, you just use multiplication and division, just conversion factors, something over something else, times, and then same thing. You just keep going until you get what you need on the top. You got to be solving for those units. You're given those units. You're just multiplying, and you try and get to the units you need from there to there. So that may sound very arbitrary, but we will get to many more problems where I explain in depth on how those actually work. So I'll catch you in the next video.